Hi guys, it's Mr. Holding. This quick video is just looking at the use of ticker tapes to study motion essentially. And this thing here is the ticker at the moment. And the way it works is we run a current, we use alternating current. Okay, so it doesn't work on DC, so alternating current through here, and this is an electromagnet that turns on and off. And this piece of metal along the top here taps up and down and leaves an ink mark. Okay, it just taps repeatedly, very, very fast, about 50 times a second, all right, but at a consistent rate. Why is that important? We'll explain that in a minute. In addition to that, we've got our tape, hence the term ticker tape, and we've got this little circular thing here. Now, many of you may not have dealt with this before, but this is carbon paper, and carbon paper is used to be used for copying, but we're going to use it to actually get our indentation. So every time this thing presses down on the paper, the carbon paper is going to leave a little dot. And the way we fit that here is you'll see a little pin there. You slide the pin through the little hole like that, making sure that goes underneath it, and it just sits in there like that. Okay, and then we get our paper and we feed it through here. There's a little slot there underneath the paper, if I can get it under, and then out the other side. Okay, and then we would pull in this direction. Okay, but we won't do that now. We'll just hold up a second. Okay, next we want to connect it. So as I mentioned before, this runs on AC, or alternating current. Okay, so you'll see there's the two yellow marks there. We want to attach it to the yellow over here. Okay, and like so. We want to turn it up to 12 volts, and then when it goes off, you hear it buzzing and tapping very fast. Now I'm not going to pull it, but you'll hear it. Okay, now very faintly you might be able to see, you can see that there's made a dot there. Now that's a single dot, and the reason why it's a single dot is because I didn't move it. Okay, I didn't pull on it. Okay, so I've got my thing here. So basically, if I wanted to assess motion, I could do a number of experiments here. And now this is going to be tapping at a certain speed. Okay, we said 50 a second, or 5 every 0.1 of a second. Okay, and we can pull it through. I could hang it over the bench here and test gravity by acceleration due to gravity by having a weight attached to the end. I could have a cart, or I could have a roll-up car, I could do a number of things. But for this exercise, all I'm going to do is simply turn it on and pull it out quickly. Okay, so I'll get started. Okay, and I'm going to leave it very still. And the reason why I'm doing that is so that it sits on the same point. As soon as I start moving, the dot will be away from it, and we'll see what pattern we can see based on that. Okay, so we ready? Hold on to it, and there we go. Okay, so now we've done that, we want to analyze our actual results. So we can see here, this is where we started. Okay, so we can draw a line. If I can get my pen to work, and say that's our starting point there. Now, as we said, there's 50 per second, and every 0.1 there's 5. So we're going to break them up into 0.1 second sections. So we do that by counting 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you should be able to see something at the moment. 1, 2, 3, 4, 5. All right. Now, the very first section, section 1 here, all right, we can say, we know that 5 dots equals 0.1 seconds. All right. This one here is 0.1 seconds. This one here is 0.1 seconds. And you can have a look at the difference in distance. So in 0.1 of a second, it traveled this far. Whereas in this one here, I can't even get it in a shot. It's this far. Okay, so we can see that there was a definite change in motion. We've travelled a lot further in the same amount of time. So our speed has certainly increased, so we saw acceleration. Okay, and how could I calculate the speed there? All right, well, I've got time. Well, I know this particular from here to over here is 0.1 seconds. I could measure it, okay, and express it as centimeters, meters, however I want to, and then I would have meters over seconds, and I could calculate a speed in meters per second. Okay, so now what I've done is I've gone and I've measured this, and it's 10 centimeters. Okay, so I've got a distance of 10 centimeters. I know that each 5-dot interval is 0.1 of a second. Okay, so 50 per second, which is 5 every 0.1, which is, we worked that out there. So we've got our time, which is 0.1 seconds. All right. In order to express this as meters per second, I changed that to meters, and I ended up with a velocity that in this particular section here was 0.1 meters divided by 0.1 seconds is 1 meters a second. So this section here was exactly at a speed of 1 meter per second. So now that's useful in calculating the instantaneous velocity of this particular section, but I can also use it to determine change in speed. So we saw here that in this case it was a distance of 1 centimeter and a time of 0.1 seconds. So our equation would be different because our value here would be different. Okay, and then we can use those to calculate acceleration, because we would have initial velocity, final velocity, and then we could work out the difference between the two and work out acceleration, as well as having the time intervals here as well. Okay, so I hope you found this helpful. Ticket timers are fairly easy to use once you learn how to use them and you get your head around them. So hopefully you found this useful. If you have any questions, come see me.